My name is Mark Miller. I'm going to give a talk called Developing a Big Data Search Engine. I call it 2.0 because I gave this a similar talk in Chicago back in the spring. So hopefully this is a slightly better version of that talk with upgraded slides. So a little about me. My name's Mark Miller. I've been playing around with Lucene since 2006. Lucene committer since 2008. Solr committer, ASF member. I was the PMC chair for a year, and I co-created Solr Cloud. Maybe we started in like 2009, took a few years off, and picked it back up again a couple years ago for the distributed side. So a little bit of history of Solr Lucene. First there was Lucene. Doug Cutting developed Lucene in the late 90s. He released it as open source, thinking that he could make a little money on the side, selling support and services on his little open source search engine. The various features were paid for by some interesting people. If you ever used a span query in Lucene, that was paid for by the Mormon Church. And there's a variety of interesting funders for some of the early Lucene development. After a little while, it was released on SourceForge first, eventually moved to the Apache Jakarta project, eventually made into its own top-level project, and it's basically just grown and grown. A lot of people started using Lucene to replace various more expensive search engines they had when they didn't need all of those features. And as more and more people used it and started adding the little missing pieces they needed, it's become more and more full-featured. In around 2006, Yannick Seely and Chris Hostetter at CNET started to develop a search engine on Lucene called Solr. Before that, lots of people were making search engines on top of Lucene. Lucene is really just a core search library and doesn't provide a lot of the simple services you might need with a search engine. So I built one in my first job. Wasn't very good, was kind of hard to maintain. I think there's like 1 million of those out there. So these days, pretty much people use a search engine built on top of Lucene, whether that's Elasticsearch or Solr, or other proprietary engines that are also based on Lucene. A little bit of history, since I'm going to be talking some about Lucene and Hadoop. That's kind of interesting. A lot of the Hadoop projects actually are kind of like grandchildren of the Lucene project. Lucene itself started, and then, like I said, Apache Solr came, a search server built on top of it. Doug Cutting, after he was done kind of focusing on Lucene, decided to go on and build Nutch. Nutch is an open source web crawler similar to Google. As he was trying to tackle this kind of like open source Google problem, they were running into scaling issues. Right around when they were running into these scaling issues, Google published their white papers on distributed file system and MapReduce. And so Doug and a couple other people working on Nutch said, you know what, to get this thing to really scale, we're going to have to focus on this stuff. Let's copy this white paper, let's make an open source implementation of what Google has, and then we'll be able to use that in Nutch. In the end, Nutch kind of actually got ditched because it's very difficult actually to make an open source search engine. Who runs the hardware? If the code is open source, how do you defend against gaming the system? Problem after problem. So while everybody was working on Hadoop to kind of fill in this Nutch gap, which it did fill in, they also started realizing, wait a minute, there's a lot of other really cool, interesting things we can do with Hadoop other than just building inverted indexes for a web scale search engine. So Hadoop kind of came into its own. It started spawning its own sub-projects as people started adding on to this kind of big data ecosystem. And so you kind of have this family tree, which is kind of cool, all kind of originating from Lucene. Most of these projects, founded by Doug in some form. He was the co-founder of Nutch, co-founder of Hadoop, obviously the original author of Lucene. A lot of other projects are now joining that he has nothing to do with, but he's kind of the grandfather of all this. Okay, so when talking about search engines these days, what search engines matter? We've seen search engines lead the pack. How can I tell? One of the tools I like to use that's fairly new is this site called dbengines.org by a couple German guys. They kind of rank various database and search systems. You kind of got to take it with a grain of salt. The various naming schemes of many of these systems means that you can't really get a great accurate count when you search Google or you look at Google Trends, you look at Indeed job searches. What's what, right? You can't just search for Cassandra. You're going to find 1 million things called Cassandra. You got to search for Apache Cassandra. And with problems like that, You don't get perfect numbers, but you get an idea of what engines are used most. So there's also a lot of evidence that popular search engines are using Lucene at the core, but not necessarily advertising it. And I'm going to talk a little bit about enterprise search engines. So looking at DB engines, these are the top databases in the world right now, according to DB engines, based on looking at LinkedIn skills, looking at Indeed job postings, looking at Google Trends, and kind of all these sources and mashing it together and coming up with an algorithm to rank them. Oracle, #1, has been for a long time. A lot of people gaining on it, though. So if you go down for search engines, the first entry is Solr at 11. I think the top spot we've ever been is 10, but Redis and Cassandra over the last couple of years have been moving up quite a bit. Below Solr, Teradata, then Elasticsearch. Elasticsearch has been ramping up, from 0 a couple of years ago to right up under Solr there. So you have basically in the top, 14 database systems, 2 search engines, both of them based on Lucene. If you look over on the right, we look at just the search engines they rank, and basically you have Solr, Elasticsearch, Splunk registers, and it really goes down from there. So basically what people are using, what people are hiring for, this is Lucene. Let's see. So enterprise search engines. If you looked in 2006 at who is leading enterprise search, Gartner would have said that it's Autonomy, Fast, and Endeca. So these guys were kind of the bigwigs of search. I'm sure most of you have heard of these guys. Some people haven't, but they're somewhat known. They've all kind of gone away in one form or another, or kind of hanging out. Oracle bought Endeca, Microsoft bought Fast, HP bought Autonomy. Most people on those systems were not very happy with these acquisitions, or the products kind of went away, like Fast was brought into SharePoint. So now the new leaders, in 2015, you've got Coveo, HP, and a name from a company in France that I can't pronounce, Ativio and Lexmark. I don't know about you, but I had never really heard of any of these guys. So most of them are fairly new companies. Coveo, which is kind of, it seems like the #1 leader, was founded not too long ago, maybe 2006, I can't remember. But so basically what's happened is we've got a new pack of enterprise search engines. I don't think that many people are using them. I don't think that many people know about them. I think in general, people are doing a lot of search that's not enterprise. They don't need these kind of enterprise-specific needs. And so, well, Lucene and Solr are taking share from the enterprise. If you look at Gartner stuff, the only way they kind of account for that is through Lucidworks, which is kind of an unfair way to rate Lucene and Solr against these enterprise guys. But long story short, basically, I think Lucene is easily pretty much all that matters in open source right now. And open source is pretty much all that matters to companies more and more. If you look at many of the polls, Black Duck does a lot of polls of various companies of who's using open source and why they're using open source. Every year, more and more companies are using open source. You've got 78% of the companies that they polled using open source in some way. Only less than 3% don't use open source in any way. The reasons for using it, quality has been rising up more and more, avoiding vendor lock-in, especially when it comes to search. All of these guys that were on Endeca, Autonomy, and Fast, when they switched and they found out what kind of disruption that was, there's a big move towards having core database and search services provided by open source software. So I think when it comes to what's search, who's using what for search, what's winning, it's pretty much the age of Lucene. You're either using Lucene or you're doing something kind of niche, I think. Okay, so I throw in a couple of quotes from Uwe Schindler, who's a Lucene and Solr committer, and he has this Twitter account, Uwe Says, where we collect some of his sayings, and so I just put in a couple on as we go. So what is the future of search? More NoSQL. I think more and more the search engine is kind of going to take over the world of where MongoDB and some of these document-based NoSQL engines are. Basically, if you're going to build a distributed system for something like MongoDB, you're going to basically have to do the same thing with Lucene, kind of the same architecture. You're going to have to do a document-based distributed system, sharded and replicated. But if you're going to do that with a search engine, you're kind of getting the document side for free. It's a little bit harder. So I think eventually adding search to something like MongoDB is really, really hard, adding good search. you kind of get a lot of what MongoDB gives for free when you do the distributed search thing, though. So I think eventually search starts to eat away there. More SQL. SQL is known by so many people and so many non-developers that people love to put that as the front end for anything. There's a lot of work in Solr going on right now, adding like a JDBC driver and various SQL interfaces. More real-time analytics, because search is set to do everything at like sub-second scale. Real-time analytics goes along well with that, and more people are trying to use the system for that. More system of record. As we get more and more stable and have less and less data loss issues, you'll see more and more people using search as their system of record rather than a standard database where you have to sync the two systems because you can kind of count on the database but less on your search. More scale. A lot of scale is coming. Some graph stuff. So basically, I think because the search engine covers so many areas already and has to handle this kind of distributed architecture, it's going to eat a little away at the stack. It's not going to be perfect for everything. There's always a lot of cases where you want to use the best tool for the job, but I think the search engine is going to offer more and more where people don't want to juggle 4 systems. They'll be able to do more and more of it on one with the search engine instead. Okay, so beginning of Solr. Solr started single node. It was good for a long time to be single node. If you think about it, like back in 2006, the number of people who had data that needed more than one big beefy node was not that high. A lot of what people were searching and indexing is human generated, which puts it on the orders of millions instead of billions. And a single node could, in a lot of cases, handle that. We added some basic do-it-yourself distributed for people who need to go to a few more nodes. Some people would expand that to like 100 or more nodes, but it took a lot of lifting and a lot of scripting and a lot of kind of do-it-yourself. So it's kind of an innovator's dilemma problem in that, what do you focus on? Do you focus on scale when most of the requirements coming in and most of the customer needs are fit one node? So it took a little while, really, before we started focusing on scale. And it was basically 2009, so 3 years after Solr started, and we added some basic distributed. We said, okay, let's focus on clustering now. Let's start working on what we called Solr Cloud. It was kind of a challenge because now we have a lot of people using Solr in this non-cloud mode, and now we want to add this new mode where everything is kind of automatic clustering, automatic failover. And how do you have this new clustered mode and the old Solr mode? And how do you keep the people using the old Solr mode happy while trying to ramp up new users on the clustered mode? And it was difficult, and we've been really lucky in how it's worked out. If you look at the Solr user list now, it's almost completely moved from single node Solr questions to clusterized Solr questions. So it's been fairly successful. We're still supporting both modes for various reasons, but we've actually transitioned most people over to Solr Cloud. So Solr Cloud, this is kind of one of the early graphics I made once we came up with the first system. Solr Cloud was basically taking the standalone Solr and do-it-yourself distributed search where you could just pass the address of all your various shards as a comma-separated parameter to tell it which nodes to spread the search across. This added things like central configuration, whereas before you had to have a config file on every single system and keep them in sync. Now you can put the config files in Zookeeper. It's in one place. All the nodes read it. Automatic failover. We needed it to be near real time. The old master-slave replication you had before Solr Cloud couldn't really do near real time because it's replicating large segment files rather than doing a document at a time. Leader election using Zookeeper. Optimistic locking so that you have some sort of database-like functionality, at least at a per document level in terms of transactions, and durable writes, where we added a transaction log so that if a node goes down, it can come back up and replay it. So I won't go too much deeper into that, but let's see. So after we built that, and I spent some time on that, I ended up going to Cloudera. And their focus was, okay, how do we marry Solr more with Hadoop? And if you remember those early slides, it's kind of interesting because Hadoop kind of came out of Lucene and Solr came out of Lucene. And now we also, when we built Solr Cloud, chose to use Zookeeper, which comes from Hadoop. So there's all these kind of relationships anyway. But what we decided at Cloudera is that we want to integrate Solr more fully. We're looking to add a search engine to our enterprise data hub. People want to have an easy search option that's just kind of well integrated and works with all the various other Hadoop components. And so part of the reason I chose to go and work on this is I saw it as the next evolution of making this Solr cloud automatic clusterized stuff really scale and really good by kind of marrying it with some of the Hadoop technologies which have a huge user base and scale really well and have been hardened over the years. It's part of why we chose Zookeeper to base most of our leader election and cluster management on, because it's just so well tested by Yahoo over time, has so many downstream users that help fix bugs and report things back. So it's been great. For when we use most of the Hadoop stuff, usually Solr is the more immature code, and it really lets us kind of leverage a system that's more widely used than search, basically. So we spent a lot of time integrating Solr with HDFS, integrating it with MapReduce, Spark, Flume, HBase Sentry. A lot of this comes down to ETL and data loading. Solr and Solr Cloud is not the best system for loading tons of data, for doing large-scale ETL. Hadoop is a great system for that. So if you have easy connectors, all of a sudden you can do that stuff where it makes sense in Hadoop on your huge 500-node cluster, and then you can send that stuff down to Solr in various ways, either using Spark, Flume, MapReduce, HBase, etc. So now it's pretty much all about scale and correctness. We've covered all the basics. We have all the basic features. We're trying to harden this thing. So the next step is to be able to kind of handle Hadoop scale, huge clusters easily, without needing a team of very specialized engineers. You can do this now. People do it now, but it's really hard. It takes a big team. You got to deal with a lot of issues. We want to make it so that that's not the case. You can just spin this up. You don't need a team. You don't need to be an expert, and that's what we're working on now. Another quote by Uwe. In my opinion, the whole code is a bug by itself. He has some hilarious comments for people who try to contribute. So the call me maybe test. There's this guy, Kyle Kingsbury, who's become kind of famous because he spends a lot of time testing distributed database systems and kind of seeing how they live up to their CAP promises. It's a big focus on causing random partitions and making sure the system accepts data like the way it said it would, and that the data is consistent across all the replicas, et cetera. Most systems he tests fails pretty bad if you read about them. Zookeeper passed really well compared to most systems that have been tested. He's never actually tested Solr Cloud itself, but Lucidworks spent some time setting up Jepsen, which is the tool he used to do this test. They spent some time setting that up with Solr Cloud. It actually did really well, largely because of how much we leveraged Zookeeper. It had a couple issues that he found, that there's some Jira issues up. I think most of them have been fixed. Maybe one or two have not. But yeah, we've done pretty well. So what does that mean? Actually, it's like a very minimum bar. This testing, people are very upset when things don't pass it and very happy when they do. But it's really just a bunch of kind of random things that it tests where you could pass them all and still lose data like a sieve all the time, still have 100 bugs where the thing basically doesn't work, but you can pass this test. So basically, it's kind of the case that search engines right now, and most databases in general, are pretty flaky at scale. So search at scale is flaky. Yeah, so I don't know if you've used Solr Cloud or you use any of these basic search engines, then if you do, if you use them in production especially, you know they're flaky because you're building systems around the fact that they're flaky and you have to deal with that. So that's pretty much how we get away with it. People are used to this. If you trust all your data in an automatic clusterized system, then it takes one bug to kind of wipe it all out. So in general, you're already dealing with that. You're either going to 2 clusters or you have some sort of backup strategy. And so people are kind of working around the fact that search is still flaky at scale. But we're trying to make it not so flaky, you know? You're never going to make it perfect. There's always going to be more bugs. But there's kind of an acceptable level, right, where people are happy to use and trust your product, where it's not ever going to be 100%, but you've kind of gone to a point where, databases are right now. Like you generally trust your info to a database. You put it in, and you almost never lose it. Although if you look, there's a group of researchers that did some testing of various failure scenarios where they would just look at the ways that files could be altered on a hard crash, and they would simulate them just by writing out the right data in that file or cutting out the right data, and then restart the database and see how they worked. And pretty much every database they tested failed some scenarios. So it's like they're good enough, but we can prove that they're not perfect. But you just need to get to that good enough level, and that's what we're working on with search. Search in particular is really hard to scale. It's a many-faceted beast. It's not just like distributing documents. It's not just like a distributed hash table. You've got to deal with a lot of different kind of random features. It's not just like get document, put document, although you do have to deal with that too. So it's really hard to get it all to integrate well and to get it to all be sub-second. People, when they think search, want every request for whatever they can do to be sub-second, basically. And so pretty much everything we build has to fit around that. And it's hard to scale that way compared to just adding and getting documents or something. So how are we going to get there? How are we going to get all this scale to work? It really comes down to testing. And we have a good foundation for testing. Lucene is really, really good with their testing. The committers are kind of obsessive about this. Lucene regularly finds bugs in new Java releases. We actually get many of their releases early to run our tests against them because we often find things and report back to the Java team and they fix them. It's really well tested. It's kind of easy to test because it's not distributed. It's very self-contained, compact code. Yeah, so let's see. A lot of what we do is randomized testing, where we inject random parameters, random scenarios with reproducible master seeds so that you can duplicate that same random run again. This kind of just expands the world of what we're testing by quite a bit. We have something also called test beasting, where like you'll take one test and you can run that test 100 times, maybe also in parallel. So like I'll often be running a test 100 times, 6 times in parallel, so that you can just make sure, especially with the randomized testing, that you've covered as many permutations as possible. So all this has been really awesome for Lucene. We've actually sucked up a lot of it in Solr. There's other things like code checkers, certain API calls that we know are kind of tricky, like where you're supposed to, if you want things to work well in a search engine, you generally have to specify like the correct locale and whatnot. So we kind of ban all the various calls that use the default locale, many other kind of things, many different like static level checking things. So it's pretty important to do this when you have a huge team working on things. As new people come in and they don't realize a lot of the previous stuff that was done or previous mistakes that were done, the more auto checking you can do on the code that they put in, the less bugs that they introduce. So this has been really important. Hard part is who's policing the policemen. You have all these checkers and whatnot, but somebody's got to be on top of them, updating them, maintaining them, etc. So you really need a good, vibrant community that cares about this stuff. Lucene has a great one. Solr has an okay one. We're kind of, I think, trying to catch up with that culture. Another Uwe quote, which is a great one. Okay. So testing is the key and the answer. The only way to get this to this scale and to get this solid is more testing. Because the other problem is a distributed system is like a random thing. Someone comes along and they poke it in one place and think they fixed something, and maybe they broke it in 6 other places and they don't know. And it's really easy to do that. And so the only way to prevent it is testing and our test framework. Like in my mind, if you don't have something that tests a specific feature, it's actually broken, even if it works right then, because it's probably not going to work tomorrow. We have like 30 people committing all the time, and things are changing all the time. So the testing is really important. Our test framework exposes a lot of problems quickly. It has huge pluses and minuses. Some of the minuses are most of these tests have lots of problems, and so a lot of them are failing all the time. That's a downside. When you can't kind of count on your framework to always pass, you don't know if your new changes are the reason these tests are failing. The upside is that you are seeing all these fails and problems because they do exist, whether you're running those tests and getting those fails or not. But it's kind of this balance of having to stay on top of all these fails and track them all down, as well as new fails are coming in as people introduce them. So it's difficult when you do all this randomized testing, when you do all this parallel tests, especially with a distributed system. There's so many ways to fail with various timeouts and false fails. There's so many different real fails. It's challenging, but this is the key. So more on testing. Integration and unit tests are equally important. I've always had this argument of like what one is more important. A lot of people think unit tests. For me, it's integration tests. That's how you know everything actually runs. Unit tests are important because when you're developing and when you're changing things, they're really great to have. But if you don't have integration tests, then you don't know things work end to end. So basically, communities grow, communities change. If you don't have tests ensuring things work the way you expect, you can't count on it tomorrow. And so this is really important. So distributed testing takes more. Most of those Lucene tests don't have a lot of false fails. It's really easy to write a nice, compact Java code Lucene test. You don't have any web containers involved. You don't have multiple instances of anything. It's just like a tight test. With distributed testing, we're spinning up multiple jetties. We're having all sorts of timing things. And so there's just so many more ways the system can fail that it's hard to make the test as solid. And we've been working many years trying to make them more and more solid. The other part is that you don't just want to run these unit tests in one JVM the way we generally do with Ant. You need to actually test this thing on real hardware. Like, you know, it kind of changes the game. Until you've actually tested it on real hardware, you don't know what various little other things are going to pop up. And that's really hard. Our project doesn't do that. And so this is where other companies are going to have to come in and help us out. And Cloudera is going to start doing this, and some other companies that have resources and hardware are doing this. But basically, you need a testing system that's beyond what we're doing within the project, that can deploy real clusters and take down real machines and do this testing for real. And it's hard because it's expensive, especially to do it at a real scale where the test is actually meaningful. It's expensive and takes a lot of time in building out the tools to easily, you know, deploy these things and break them down. But they're important. Let's see. Okay, regular large-scale testing will be a challenge. So this, I was doing a 1,000-node test. It's actually like 994 because you can never keep all of your nodes up, apparently, when you have 1,000. But so this is going to be the real hard thing, is like, we want this Solr Cloud thing to work at 1,000 nodes. The only way to know that it works at 1,000 nodes and that it works at 1,000 nodes tomorrow after 5 people have checked in new code is to be regularly testing it on 1,000 nodes. And it costs a lot of money to always run 1,000 nodes. So this is going to be difficult. And hopefully, as more and more companies get involved with this kind of scale, we're going to have some kind of outside help with this kind of scale testing. Yeah, so the race for scalable search is on. We're all pretty flaky right now. But at some point, one of us is going to be kind of at the Hadoop level where we've kind of matured. Hadoop was pretty flaky back in 2008, 2009, whenever, the early days. It's been years now with tons of development, tons of money, tons of people, and it's really hardened. And we're hoping to get to a similar place with Solr Cloud. So yeah, I'm going to basically leverage Hadoop a lot because I work at Cloudera, and Hadoop is easily in our world. And Hadoop is already kind of scaling to places where we would like to get to, and we're not there yet. So there's some cool things also that we can do with Hadoop. When you have a distributed file system, for example, we can have one copy of the index that all of the replicas share as one option. That's a thing I'm working on now. And there's also other minor cool things you can do. Like I mentioned before, ETL at scale is not Solr's strength. And if you're going to have 1 billion, 2 billion, 8 billion documents, unless you're building that up kind of naturally, it's very difficult without Hadoop to load that kind of data into Solr in a reasonable time frame. So Hadoop will push Solr to its limits. We're integrating Solr into Hadoop with Cloudera Search. And as we try to offer search to people that are doing things at Hadoop scale, more and more of them are going to be doing search things at Hadoop scale. And so hopefully it's going to help push Solr Cloud to scale more and more. Couple links to some of the testing tools that Uwe has. His Forbidden APIs tool. If you work on a project, that's a fantastic static checker that lets you forbid various API calls that are a little tricky. And then the randomized testing framework, which is kind of what Lucene is based on. And you can, if you use JUnit, you can base any kind of test suite on this randomized testing framework. It gives you a lot of tools to do a lot of the cool stuff Lucene and Solr are doing. And yeah, so I've got about 10 minutes left. That's pretty much it. Any questions?
My understanding is that currently the Solr direct connect to the Hadoop is the HDFS. So with the HDFS, my understanding is to give the functionalities you have only need to solve. But this brings an issue if there are any performance issues since all the data is loaded from the remote.
Right. So the question is kind of like integrating Solr with HDFS. Are there some issues? Because one, it may not be local, and two, now you don't have M mapping. Like how do you deal with this? So basically, to deal with HDFS, what we've done is created what's called the block cache, which lets you basically have a cache that is a replacement for the local file system. It's off heap using direct byte buffers. And so it's not necessarily going to be as efficient as M mapping something and having your local file system cache, but it's generally, in our experience, been good enough. We want to improve it. We actually borrowed this implementation from the Apache Blur project, and I think there's some things we can do to make it more efficient. But it's basically our crutch right now to get away with dealing with non-local data, for one, and for just kind of speeding up talking to HDFS in general. There's still a lot more to do in our integration with HDFS. The reason that we're focusing on that is because if you're already using the rest of the Hadoop stack and you get to manage all of your disk space just via HDFS, it's kind of annoying then to also have to go and deal with local disk space for something like Solr. You really want to be able to have one distributed file system that you're running all of your apps against. It's just a better, easier management thing. So there are some performance hits when you use HDFS instead of local file system and some issues, but over time we hope to keep improving and making that better. It's always going to be a little different because it's always going to be a distributed file system versus the local one, but I think we can kind of close the gap. Any other?
A question about using Hadoop to bootstrap into law the data in Solr. Does that mean that you will run MapReduce Job and create the segment files and then the load of segment files to Solr? Something similar as, for example, HBase does to create the H files? Or is working in another way?
Yeah, so the question is, how are we using Hadoop to get the data into Solr, or Solr Cloud, basically? And so it depends on what you're doing. So if you really want to build as fast as possible, we do it with a MapReduce job. We have an integration with MapReduce where you can say, use my entire Hadoop cluster and MapReduce build all these shards and then merge those shards down to the number of shards you actually have in your Solr Cloud host, and then it's just a matter of copying it in HDFS from where you built it to where it needs to go. If you're doing something like Spark that you want to be real time, that's actually feeding into Solr like directly. And so that's not going to be great for backloading tons of data. That's for kind of when you have near real-time data coming in. Same as with Flume, near real-time data coming in, there's a Solr sync, it will just go into Solr. Those ways are for like, if you've got data naturally coming in. Pretty much if you've got a backlog, the solution is the MapReduce job. That's pretty much the most efficient way you're pretty much going to do it. That's how Google builds their indexes, basically. That was the idea of building Nutch, and then Hadoop was to have this functionality. 5 minutes. Any more questions? Or, sorry, let's go to a new one, and I'll come back to you after.
First of all, thank you for the work on the emitter. Really much appreciated. Second, I really like your look back saying, oh, Solr started a single node. It took a while until we understood, distributed, it wasn't as fast enough. Now we have a Solr cloud. I'm curious, what's the forward-looking thinking? Do we see anything that, as in the back when we started single node, we took a while to understand distributed. Now we have distributed. What's next? Do you guys look beyond Solr cloud?
Yeah, I mean, I think there's a lot more time of hardening. Hardening this thing is really hard and takes a lot of time and a lot of use. The more users we're getting, the larger users we're getting, the more it's hardening. But that's like where most of my brain is on getting this thing hardened, and that's going to be still years out, basically finishing that. But what's happening a lot around this is now that we have this distributed system, is people are using it to build on. Like a lot of the SQL stuff that Joel is doing is like saying, hey, we have this distributed system. What other random tools can we kind of plug in on top of it? What kind of analytics stuff can we now plug on and use this 500 node Solr cluster to deal with? So I think a lot of it is just going to be more SQL stuff, more no SQL features, more analytics features. The stuff I talked about on that slide that are just going to be built on top of our distributed system. And as our distributed system gets more solid, I think it's going to be more enticing to come and plop more of that random stuff on top. For me, though, it seems still a long ways out before it's as hardened as I'm going to be happy, so that's going to be the focus for a long time for me, I think. Do you have one more?
Yeah, okay. One more question. That is not really the Solr cloud. Okay, because so basically, one thing block we into the Solr cloud is today, like if you use the Solr cloud, you have to run very well. At the beginning, you have those 2 shells. But since the business grows, when it grow from 4 to 6, 9 to 8.
Right.
Today we have the problem is since I think now understand we need to rebalance.
Yep.
Rebalance, stop the service, rebalance the data from the 4 to 6. Is there any plan to design improvement for?
Yeah, there's definitely, I think, going to be more automatic stuff that comes in for rebalancing, for shard splitting, for all of that. I think it's just a matter of priorities and who needs it and when they're going to get there. It's going to probably be optional. A lot of that you don't necessarily want automatic, but I think we're going to have automatic options for all of that, where the cloud will just be smart enough to say, hey, these guys are too big. We have these additional hardware. Let's split them. Let's move them. I think there's going to be a lot of that. There's nothing I plan to work on in the short term necessarily, but I think it's coming eventually. Okay, I think we're out of time, so thank you very much.